so today we're going to start our study of differential equations. Differential equations are super important in tons of different fields, so starting to know how to solve them is going to be a very important step today. Alright, so let's start by just what they are. So I'd say that a differential equation is, I'll often use DE just to shorten what we have to write. So differential equation is an equation. It's not going to be an equation and a variable. The unknown will not be a variable. The unknown is a function. So in an unknown function f, and that equation will involve f and its derivatives. That's why the differential is there. So it could involve f and f prime, f prime, f double prime, and so on. So any of its derivatives. So our goal is to find the function f. So there will be two types of solution. A particular solution, for a differential equation, well, that would be one specific function, a real function, completely determined, for which the equation is true. Is one specific function for which the equation is true. Now what we're after is a bit more general than this. In fact, it's called the general solution. So the general solution for a differential equation will be not just one specific function, but an expression that includes all functions. So it's an expression that represents not just one, but all potential solution, all particular solution of this differential. Alright, so what I want to do is I want to give you a differential equation just so you can see what it looks like, and then I'll give you a particular solution and I'll give you the general solution so you can see what the difference is. So I want y prime. So y is my unknown function. Y prime equals y plus 5. Y plus 5x. Actually, let's write it with f's for the first time. Alright, so the derivative is equal to the original function plus 5x. Right? An equation involving an unknown function that we're looking for and its derivatives, that's a DE. give a name, a label for this equation. Let's call it star. I want to check that this specific function is a solution. So it's going to be a particular solution because this is a completely defined function. I can evaluate it, I can graph it, I know everything about it. Alright, so we need to check that this fits, so the two sides are equal. The left-hand side is f prime. If I differentiate this, I'm left with minus 5 plus 0, so just minus 5. So that's the left-hand side. The right-hand side is f of x plus 5x. The minus 5x will cancel with the plus 5x, so the only thing I'm left with is the minus 5, which means that it agrees with what the left-hand side evaluated to. And so yes, it is. Alright, so this is a solution for this differential equation, but it's not the only one. And so that's why we need the general solution. The general solution will give you all the different solutions. So let's leave this here for now so we can use it in a second. Alright, so let me say that I claim that the general solution, and let me give you a formula for it. Is f of x equals c e to the x minus 5x minus 5. Alright, so you can see the minus 5x minus 5 that I had in A, so that would be one specific solution, one particular solution, but that solution would be only one of many, so that would be the one for c equals 0. But any value of c I claim would give you a solution for this, so let's check. So I'm going to do the same work I did here. I'm going to check that the two sides agree, except that instead of having one specific function, I'll have a constant c that I don't know, but hopefully will not get in the way. So I want to check what f prime is equal to, and I want to check what f of x plus 5x is equal to, and hopefully these two sides would agree. Alright, so c e to the x minus 5x minus 5, that's going to give me c e to the x minus 5. That's it. Now, if I take my function and I add 5x to it, these will cancel, and I get c e to the x minus 5. And yes, the two sides of the equation, the left-hand side and the right-hand side, agree. And so, yes, they are solutions.